So far, we've asked, how fast is the outbreak growing? Now it's time to ask, how much has it added up to? That's where integration comes in, your math-powered totals tracker. During an outbreak, we don't just care about how fast disease spreads. Enter the power rule for integration. Calculus's answer to the question, how much disease burden are we really dealing with? The integration version of the power rule is surprisingly elegant. Just add 1 to the exponent, then divide by the new exponent, n plus 1. Boom! You've accumulated change over time. Let's say you're modeling a 14-day waterborne outbreak using this curve. To find the total cases over the 2-week window, integrate from 0 to 14. That's not a guess. It's a precise estimate. And it's immediately actionable for supply chain planning, resource allocation, and early alerts. So why should you, epidemiologist, data analyst, or professor, love integrals? Planning. Turns rates into real-world totals. Comparison. Compare outbreaks across cities or years. Evaluation. See whether you actually caught all the cases, or just part of them. It's like converting speed into distance traveled. And that distance? That's your public health impact. In math speak, the total is the area under the curve, AUC. In public health speak, it's total infections, total test yield, total treatment uptake, cumulative vaccinations. This is how integrals help convert incidence into impact. This isn't theoretical fluff. Public health teams use these methods to forecast ventilator demand, model recovery curves, track cumulative exposure, time interventions with real math. You could eyeball it, or you could let calculus carry the load like the public health superpower it is. When the question becomes how much, you've left the world of slopes and stepped into the world of sums. And that's where integration takes center stage, turning curves into answers and data into action. Now, here is a small practice problem for you. Use integration to solve this simple word problem. Give your answers in the comments. Hint, we did something similar in this video. You will use the definite integral and the power rule for integration. Have fun!